Hello everybody. Hello everybody. Welcome back to my YT channel. This is again I'm a singer, eternal voice. So it's good to see you back. Okay, doing another live stream, like a live stream for another topic. And chemical engineering. I just okay. We got. It's gonna be like that. So actually, the topic is not very difficult. It's just very easy. I'm not very easy, average. All we have to do is to read carefully the problems and analyze it well so that we can solve what is being asked in a particular problem. Okay, guys? Actually, on the spot, because I just screenshot this one. I didn't solve yet. Let's see if my memory works. Okay, what's this? Question number one. Oh my god. Okay, I screenshot. What else? Hello. Ka? Hello. Ah, I cannot use the microphone. Low bat. Okay. So where is that? I think we gonna solve one or two problems this time. Okay. Where's that? Kaloka. So let's check that here in my mobile phone. Oh my gosh. Tadadun, 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 tadadun. Oh, tadadun, tadadun. Ah, yeah, this one. It took a long time, right? Oh my gosh. Oh. I think it's another phone here. Okay, I think it's here. It's not there. Unprepared. Kaloka. Okay. What's that? Gallery. None. Oh, okay. Oh my gosh. It's not here. Oh, where is that? It's not here. See the screenshots. Oh my gosh. It's not here. Wait for a while. Screenshot. Oh, it's not screenshot, but actually that is gallery. Wow. Gallery. It's camera. Yeah, it's here. Question number one. Iodine is produced by the reaction of 0.4235 moles of cuprous chloride according to the following equation. 2 moles of cuprous chloride plus 4 moles of potassium iodide is equal to 2 moles of cupric iodide, cuprous iodide plus 4 moles of potassium chloride plus iodine gas, I2. How many molecules of I2 are produced? What mass of I2 is produced? Wow, kaloka. On the spot. So the question is like this. Okay, write in the whiteboard, right? Makita ninyo? So it's gonna be I2. Question number one. Oy, di makita. Did makita in fairness? Ganun. So I2, makita digri. is produced, ganun, is produced di makita by the reaction. Okay, wait, di makita. Ay, bali lagi. Okay, by the reaction of 0.4 to 3.5 mol of cuprous chloride according to the formulation. According to the klaro, guys. Did you klaro, no? Wait. According to the following equation. Actually, this is chemical reaction. Okay. So 2 moles of cuprous chloride. The reaction is already given, and you don't have to worry to make your own chemical equation. And then we're trying to balance after this, right? Okay. See to it before going further, because the important in the chemical calculation is you have to balance the stoichiometric relationships regarding the amounts required or whatever. You need to balance that one, okay, so that you can really solve what is being asked. If not balanced, you produce an error of your answers. Okay, plus 4 moles of potassium iodide. Okay, 2 plus 4 potassium chloride plus iodine. So in this reaction, guys, oh my gosh, in this reaction, 2 moles of cuprous chloride plus 4 moles of potassium iodide is equals to 2 moles of cupric iodide. I think so. This cupric, right? Or cuprous iodide pa rin siya. Okay? Yes. Plus 4 moles of potassium chloride plus 1 mole of iodine gas. Take note, if you have the iodine here, it will exist as a gas in the product. That is your first identification. Here. Anything that has, an iodine like that. What's iodide, chloride, what else? Iodide, chloride, bromide, fluoride, the halogen family. Under the halogen family or the halides group, something like that, that has a valence or a charge of -1, something like that. Usually, that is came from the compound. Uh, Naturally, it will be the product. So that is your first identification. Okay, this one. So it's become iodine gas from here. So ingana siya. Okay, then after that, you need to follow the, what's this? Compound plus compound. This is double replacement or double displacement type of chemical reaction. Something like that. So if you try to, so this react with the chlorine and potassium, so it will become potassium chloride. It's in here, the product. And then we have the cuprous and the iodide, and the cuprous cupric iodide is in here, plus the iodine gas. So ayaw kumpiyansa nga, dili jud mo butang ang iodine gas, kay di na siya mabalance. Okay? For example, here we have potassium, sodium iodide, sodium fluoride, sodium, what else? Chloride, bromide, like that. Okay? So it exists as an what do you call this one? Diatomic gases. Diatomic gases. Okay, this one, iodine gas. Okay, chlorine gas, bromine gas. Okay, what else? Chloride gas coming from the halide, iodide, chloride, fluoride in a compound. Okay, get the point? Something like that in your chemical reaction. It's gonna be like that. Okay, so you need to observe properly. Now the question is, what's the question is all about? So you need to compute for the wait, huh? Again, it's lost. Okay, so how many more molecules? Okay, it's asked for the molecules. So molecules of iodine, molecules of iodine. Take note of molecules, huh? It's not mole. What is being asked? It is not also atom. What is being asked? Okay? So that is letter number one, or letter A. Letter B. Okay, guys. We need to solve for the what mass of iodine is produced. Mass of iodine is produced. Iodine gas produced. If you put two on the subscript, that is a gas. Diatomic gas. Di stands for two. Subscript. Something like that. Okay? Produce. Okay? Actually, if you can really visualize the problem, you can see that this is easy problem. Or for example, if you are joining in a quiz bowl or a chemistry quiz bowl or a science fair, this is an easy round, something like that. But take note, this is also a tricky question. Okay? If you don't memorize something, later on I will tell you what happens if you will not memorize something. Okay? Like that. So A, molecules of I2, and take note the chemical reaction here. Okay? Okay. Actually, there's a lot. You will start with a cuprous chloride or potassium iodide or cuprous iodide and make your calculations, What do you call this one? Conversion calculations. Cancellation, something like that. Actually, there's no exact formulas and equations to be used. This is just only conversion thing. Okay, very common in general chemistry lecture. And your ideas for this will be used in your higher chemical engineering subjects, or shall we say BS chemistry subjects in higher chemistry, shall we say reaction kinetics, physical chemistry, unit operations, thermodynamics, something like that. Sometimes thermodynamics also deals with chemical reactions sometimes, but not most of the times. Okay? Usually the physical chemistry, and then the chemical calculations or the stoichiometry. This is very popular in stoichiometry in your chemical engineering subject. Okay? Now, you can have any options. You will start with the cuprous chloride as your basis of calculation. You can start with the potassium iodide for the cuprous iodide, potassium chloride, and iodine gas. Okay? Now I will choose cuprous chloride as my basis of calculation. So this one, right? As what I told you, numbers put beside the compound or an element is what we call as the number of moles. And then the number of atoms will be the number of coefficient times the subscript. Okay? For example, if we have this compound, copper chloride, and then the copper here, the copper, C here is a symbol of copper, and then there is no subscript in this copper. Then you can say 2 times 1, understood to be 1. There's no number in the subscript. And then the chlorine, there's a 2 subscript. So the number of atoms will be number of coefficient 2 times 2 the subscript is equal to the 4 atoms. Okay? So molecules is the entire substance. Okay, that considering the theory that you should memorize. And this is now what I told you later. Okay. 2 moles, solution letter A, charot. Okay. Solution letter A. Ganon. Sa letter A ta. So, 2 moles of cuprous chloride, okay, times, ganun siya. Since you're asking for the I2, okay, pila man ang I2 in here. I2 is sa product because you cannot see an I2 in the reactant. So it should be in the product. So 1 mole of I2. Okay? Like that. Then supposedly it's gonna be like that. But take note, this is still cuprous chloride. And understood to be the denominator here that you will be multiplying is also cuprous chloride. It's not yet the iodine gas. So this is the my memory works because this is on the spot solving actually. Okay, so I did not prepare anything based on my stock knowledge. Then I have to solve directly without preparation. So that's why I thought it's gonna be like that. It's gonna be like this. Cuprous chloride, your denominator. Okay, since this is mole, mole also your cuprous chloride, so that it will cancel out. Okay, mole. Okay, cuprous chloride. Okay, so 2 moles of cuprous chloride. Since you have already 2 moles of cuprous chloride in the reaction, you don't need to look again in the reaction because you used that already in the reaction. You find another way to have number of moles in the cuprous chloride in which it is not referring to the chemical reaction now. So what is that? Okay, very basic in chemistry lecture 1, it's gonna be considering the molar mass. Okay, the molar mass or the molecular weight of cuprous chloride. Now we're gonna break this cuprous chloride into copper and chlorine. And now, cuprous, what is the atomic weight of cuprous? I don't have the periodic table here, then I have to Google that out. And we are not very, very lucky if the Google search will produce a wrong molecular or atomic weight of the copper because it is not expected always at the perfect in Google, sometimes wrong. Okay? Later on we will analyze. It's gonna be 63 point something for copper based on my memorization. 63.54, but I don't know exactly what really is. I have to Google search. Let's see. Copper atomic weight. Atomic weight because that is only element. Okay, that is not compound. If I will say compound, that is molecular weight. Since element only or metal or like that, blah blah blah, that is only atomic weight. Okay, but atomic weight and molecular weight, you can call that both as molar mass. Okay, I can say molar mass of copper. It's okay, correct. I can say also 1 mole of cuprous chloride or molecular weight or molar mass of cuprous chloride is still the same. Di siya mo matter whether it's element or compound if you use the term molar mass. But if you use the term atomic weight and molecular weight, be careful because this is just the same as English. Okay? Singular, okay, is, plural is are. Okay? Past tense, singular is was. Past tense of the plural is were, WERE. It's just the same. This is chemistry grammar. Okay, if we have English grammar, Filipino grammar, we have also mathematics grammar, we have also chemistry grammar. And this is chemistry grammar. Okay? Why? Because atomic weight is singular because it's only referring to element or a metal or a non-metal or a gas. Okay? Monoatomic or diatomic. Basta usa lang yun siya. Okay? Now for compound, it is molecular weight. Okay? So you will never say the atomic weight of cuprous chloride. Wrong chemistry grammar because cuprous chloride is a compound. You will say molecular weight instead of using atomic weight. You get the point? Okay, that's very clear. Okay, now, so copper, ato siyang tukion, okay? So that we can really understand, okay? It's just like English grammar, so that it can help us to understand well. Okay, punto per punto, ganon. Okay, copper, atomic weight. Kaloka. Yes! my memory works. That is 63.546 gram per gram mole. Okay? Okay, so gram per gram mole. So actually, this is gram per mole. Guys, all books and all textbooks using gram per gram mole actually it's just the same with grams per gram mole because in every 1 gram there is 1 mole, something like that. So gram over mole or gram per mole is just equal to gram per gram mole. This one here, mole is just equals to gram dash mole. Okay, some books still use this gram mole, but actually that is also mole. Okay, the basis of calculation there is gram. That's what they put prior to the word mole. Gram mole. That actually is just the same with mole. Don't be confused with the word gram. Okay? Ganon. So, mole. Mole. So, mag-cancel ang mole mo. Cancel phosphorus chloride. Okay, pareho mo sa siya. The same compound. And then grams sa taas. So, this is molecular weight. Cuprous. Okay. Since copper pa siya, 63 point. Sa pila ko siya ako nakuha, guys. Weight. 63.546 pa. Gram per atom. Phosphorus chloride is compound. That's why gram mole. But here, copper gram per atom pa siya. And then chlorine. Chlorine, I think it's gonna be 35.454 based on my memorization. Okay? As a chemical engineer. Wow. So we are fun and loving of memorizing atomic weight and molecular weight, right? Common substances. Let's say if my memory works also for chlorine. Okay, that was 20 years ago. Okay. Chlorine atomic weight. It's gonna be 35.454 for like that. Okay. Okay. Yes, correct. Nakakaloka. 35.453.01 lang ang mistake ko in my memorization. Okay? 35.453. Or basically, 35.453 gapon. Okay? Ganon. Ako, ano yung i-memorize ang mga common lang yun, guys. That's why. So, copper, 63.456. Okay? And 35.453 for chlorine. Gamay natin kung diferensya, 0.001 lang, no? Di ba na mamatter siya sa calculation. Okay. So, gram per gram atom. So, copper, 63.546 gram per gram atom plus 35.453 gram per atom is equal to grams per gram mole. Already, because compound na siya. Now, this is chlorine. So, subscript will be multiplied by the atomic weight or atomic mass of chlorine. So, times 2. Ganon. So, I need a calculator to make it fast because I have another appointment. Charot! Kakaloka? Ganun siya, guys. Wait, guys, ha? Excuse me for a while. By the way, class, charot. By the way, class, shout out to Ma'am Agnes Abalo, in which I failed to help your daughter for chemistry assignments because that time I was very, very busy in monthly reporting in OSH. And then I have so many vlogs at the time also, and I have other appointments, and I forgot to help you. Maybe next time I can help you. She asked me about, chemical equations, balancing of chemical equations, okay, for the assignment of her daughter. Please forgive me next time. I will do, okay, inshallah, okay? I bigger apology for that, okay? Ma'am Agnes Abalu, okay? Sorry, okay. Now, 35.453 times 2. Ganun siya, chupa-chucho. Kaloka. Ganun siya, guys. Diba? Okay. 35 atomic mass, or atomic mass and atomic weight is just in the periodic table of different substances, whether it is solid, liquid, or a gas. Okay? Because when we mean of a substance referring to the periodic table, the gravity is not an issue. Get the point? The gravitational pull in the Earth surface is not an issue because we are not referring to the dropping of substance in the ground or motion, and this is not also physics. Okay, that's why atomic mass is just equal to atomic weight. Okay, guys, so it should be technically correct both. Okay, but familiar kasi kayo ang atomic weight ng atong iyaw-yaw. Okay? But actually, it's just also the same with atomic mass. Atomic mass of copper and atomic mass of atomic weight of copper, atomic weight of chlorine. Okay? Dili issue ang downward motion. Walay gravity. That's why. Okay? Ganun siya. So, 35.453 times 2 is equals to 70.906. 70.906. This is still gram atom. Then gram per gram atom plus gram per gram atom, or gram per atom plus gram per atom is equal to gram per mole of one compound. Add na mo siya. Okay? Total 70.906 plus 63.546 is equal to 134.45 grams per mole. Now, we have the mole here in the denominator, and we have the molecular weight grams per mole. So multiply it directly, copy the number. This is 134.452 grams per mole. Grams per mole of corpus chloride. Cancel the moles of corpus chloride. What we left is the grams of cuprous chloride. So, ato na siyang putlon-putlon, guys. Actually, we can do the lengthy conversion, but there's not enough space in the whiteboard. So, I must cut it off and start another continuation of the solution because to save space. Okay? So, let's compute first for the gram of cuprous chloride. Okay? So, 2 times 134.452 is equal to 268.904 grams of cuprous chloride sa atong papason. Okay, because there's no other space. Okay, so may letter A pa ta siya. Okay, so 268.904 grams of cuprous chloride. This one. Since we are asking for the molecule, how can we do that? Okay, how can we do that? Asking for the molecule. Okay. So, let's see. 268.904 grams per chloride. Okay? Ganon. So, saan man mo siya ron? Okay. Balik ka sa chemical reaction. Okay. 2 moles of cuprous chloride. Okay, ganon siya. Mubalik ka sa chemical reaction niya. You get the point? Okay. Now, kung mubalik ka sa reaction, naman kayo 0.424 mole of cuprous chloride here. Okay? Nasa kadali. Okay, you get the point? So, sa una ni mo pagkalaki niya ng higayon na. Okay? So, grams ang denominator, mole ang taas. Okay? And then, mugamit din kag Avogadro number. Okay? This is the constant to be used if you will ask the molecule. Okay? Remember this because it will come out in the board examination. Okay? Asking for how many molecules of this particular substance that will react to this particular substance to produce this particular substance. Ganon. So, molecule. So, imong hinumduman sa molecule ang gi-ask, always use the Avogadro number. 6.023 times 10 to the 23 per molecule. Okay, now, ganon siya. So, Ganun siya. So, 6.023. Okay? Ganon. So, this is 1345. Ganun siya. Molecular weight niya, 134.452. Cancel ang gram. May sa cuprous chloride man siya, di ba? And this is 1 mol. And naman kay mol nga here, di ba guys? 0.4, okay? 42235. Okay? Then times 6.0 times 10 to the 23 per mol. Mol per molecule. Cancel ang mol, what will be left is the molecule. Okay, guys? Kasi 2.6.9 over grams copper chloride times, okay, the reverse of the molecular weight. Okay, wait, I reverse to cancel the grams, and the left is 1 mol. Okay, guys? Ganun siya. You got the point? Or you can also go directly, but I have to make it proper. Okay? Before going directly. Because mol naman siya. So, namin tayo mol dari-ari. So, 0.4235 mol of cuprous chloride, then times the 6.023 times 10 to the molecule per mol. Ganon. Oh, mol per molecule. Sorry, guys. Okay? So, kung anaon na nato siya pag kanang unit na mol per molecule times 1 over mol, right? So, makansel na lang mol. So, makabili ng molecule. Okay? So, muna ang unit molecule siya. Okay, molecules magipangita. Okay? You got the point? Muna siya, guys. Okay? You get the point? Muna siya. Hindi mo na siya hinumduman. Hindi mo na siya may tabo. Charot. Or, you can make it proper. Dili mo i-diretso. Ako mo na siya i-diretso good. Okay? So, sige, proper na lang yun nato. Ulit natin i-diretso ha. Dapat big space. Good way. Charot. Nakakala ko. So, times 0.4235 mol of cuprous chloride times the 2 moles of cuprous chloride in the reaction. Okay. Then 6.023 times 10 to the 23. Okay. Molecule. Ganon. Cancel, 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 and this is still mol, and this is molecule. Okay? Mali mo answer. Molecular per mol. Okay? Okay. Ang mol ni mo ani, mol, cancel siya, cancel siya. So what? This is mol of cuprous chloride. Every 1 mol of cuprous chloride, there is 6.023 times 10 to the 23 of molecule na conversion. So, cancel the mol of cuprous chloride, 2 moles of cuprous chloride, like that. What will be left is the molecules. Okay? Pila man siya. Okay? So, nakakaloka. Wait guys ha. So, 134.45 times 0.4235 is equals to 56. Ang denominator, 56.94, and numerator is 268.904 times 2 times 6.023 exponent to the 23 is equals to, divided by 56.9 is equals to 5.69 times 10 to the 24 molecule. Grabe. Imong timanan guys, basta mga molecule gani, tag-as kay siya answer ha. So 5.69 times 10 to the 24 molecules ang A. Okay, that is for cuprous chloride. Okay, it's reasonable because we are asking for the I2 pa pala siya. Okay, I2. So this is for cuprous chloride pa man din siya guys. Okay? So wala pa matanaapot. So 5.69 times 10 to the 24 molecules of cuprous chloride. Ganon. Now, ang iodine. So, 1 molecule of iodine. okay, of iodine. Ganon. So, pila may kuha niya? Molecules niya. 1 molecules of iodine, pila ka mole ari. So, 1 mole of iodine. Okay. So, equal na siya, guys. Okay? 1 mole of iodine and 1 mole of iodine. Like this. So, copper's chloride. Okay? Ito siya. You get the point? So, 5.6 na times 10 to the 24 moles of copper's chloride and moles of iodine in the reaction. Balance ka niya siya. Dito sa naging solve. Nakalimot ko, i-balance pa ba niya siya, no? So, let's check lang kasi balance na siya. Naglalim ko, guys. Okay, 2 copper, iodine 2, iodine 4, iodine 4. Balance naman siya, di ba? 4 potassium, chloride 4, chloride. Balance na siya. Kita gaan nag-balance na ang equation. Okay? So, 1 mole, molecules of iodine, then 1 mole of iodine. So, pilit 1. So, 5.69 times 10 to the 24 molecules of copper's chloride. Okay? Or pwede sa tiyan na mo, guys. If, ano siya answer, no? 5.69, maraming moles of copper's chloride. 2 is to ratio proportion. 2 is to 1, and then molecules of copper's chloride na 5.69. So, 5.69 times 10 to the 24 and x for iodine. 2, 5.69 over 1 over x. Ganon 2x divided by 2. So 5.69 divided pa na siya. So, 2.84. Sorry, 2.84 kayo. Kay 2 man ang copper's chloride. Okay? 2.84 times 10 to the 24, okay, molecules of iodine. Ganon. This is the answer of letter A. Okay? Di ba sa'yo kayo? Okay? Di ba? Sa'yo kayo tanan, no? Okay. So that's letter A. Letter B. The mass of iodine is produced. Alam, nakakuha naman tagram sa copper's chloride. Muna na itong basis of calculation, right? So letter B. So, times, muna siya, lagi papasag na ako ang kuhan. Ang molecular weight, sorry guys ha, akong magamit din ang molecular weight sa copper's chloride. Sorry. Okay? Nagdanghag lang dito sa. So, akong balikon. Ako na lang i-google search ang molecular weight sa copper's chloride. Kaya ako mang napapas. Sorry, I erase it. Okay? Because the, this whiteboard is very small. Okay? Copper's chloride. Actually, it is also copper chloride. The same as copper's, okay? Then this is molecular weight. Copper's chloride. 135.45. So 134.45 grams per mole. Okay. Okay. And then 1 mole of copper's chloride. Basta kung gamit ka ng molecular weight, guys, always 1 mole yung pares. Okay? Either matuwad siya in the numerator or denominator, depende as long as your purpose is to cancel out. Okay? The denominator and the other one also there. So, mag-adjust ka. So, ang imong copper's chloride sa reaction, how much? 2 moles. Okay? 2 moles copper's chloride and 1 mole of iodine gas. Cancel. So, what will left is the mass of iodine is produced. Okay, so this moles of I2. So mole of I2 is 36 molecular weight or atomic weight of I2 iodine. Okay. Diba guys? Oh. 268.10 of 4 grams of copper chloride times 134.45 grams of copper chloride, 1 mol. Then 1 mol, numerator, denominator, makansel siya. So reaction, 2 moles of copper chloride, and reaction also 1 mole of iodine. Take note, 1 mole of iodine pa man siya. And then we need to make it in grams because the mass is being asked. So, conversion again. So 1 mole of iodine, pilay atomic weight sa iodine. Ganon. Of iodine. Wait, so that is 126 iodine. Wow, 126.90. Ang iodine, taas kayo siya atomic weight, no? Ganon siya katindi. So, grams. Okay? Ganon. Grams per mole. So, grams ang habilin. So, grams of iodine ang letter D. So, grams of iodine. So, calculator. Ganun siya ang purpose guys. Magkasal-cancel lang siya sa denominator, and then numerator, ganon. Basta, imong i-reverse para lang yun makancel. Yung anong technique guys sa engineering. Always like that in conversion. Standard yun na siya. Okay? So, muna siya yung tabo. Okay guys? So, 1345.45 times 2. Dibati ko kapuol. Because, you know, we've been doing this for 5 years in school. So, 134.45 times 2. So, 268.9. So, again, this will repeat it from first year college, second year, third year, fourth year, fifth year college. Okay? Naalang siya additional, something, chuba, chuchu, but still this basic foundation will never be lost. Still used. Okay? 268.9. And then if you're working to the laboratory, then this will be used especially for the calculation of the concentrations of the preparation of the normality, molarity of the solution of liquid, inorganic and organic solvents or liquids in the laboratory, especially if you are a technical laboratory analyst or laboratory technician, something like that. You have to prepare solutions. It is very important. You should have adequate knowledge of the expression of concentration topic in general chemistry, including the chemical calculation also. Oh my gosh. Okay? So, ganon. So, 268.904. Okay. Times 126.90 divided by 268.9. So the answer is 126.9 grams. Sa letter B. 126.9 grams of iodine. Guys, 126.9 grams of iodine will be produced of the I2 in this chemical reaction if you are initially at 0.4235 mole of copper chloride. And in letter A, you need 5.6 times 10 to the 24 molecules of iodine to produce from 0.4235 moles initially of copper chloride. Something like that. Okay? Or you can also use ratio and proportion directly, guys. Like this. Okay, get the point? So if you have 0.235 moles, so 4.235 mole of copper chloride. Okay? And then you have also here, right? So this is initial. Kung magbutang ka direct initial. O initial moment, chupa chuchu. O ganon. Then final. So initial, meaning sa wala pa magsugod. And final, nag-start na siya. Okay? So, ganun siya. So, sa final, okay, ang imong copper chloride, wala pa ibaw X siya sa initial. Pero na kayo usa ka copper chloride nga 0.4235 na given. So, this is the actual, but you don't have the theoretical number of moles in the initial. And then the final, you have the theoretical, okay? 2 moles of copper chloride, okay? 2 moles of copper chloride, okay, ganun siya. One ang imong final. So that is theoretical. Meaning final is theoretical by theory, An initial is the actual. Okay, now, this is for cuprous chloride. So both. Okay, because cuprous chloride is your basis of calculation. It has to do something with the comparison with the cuprous chloride and the iodine. Because this is the basis of your calculation. If we try to use ratio and proportion, not the conversion way of solving. Conversion katong lengthy. It's not that. Ratio and proportion ang siya. So moles of cuprous chloride initial, moles of cuprous chloride final. So moles of cuprous chloride initial, which is our actual, even in the problem, is 0.2335 mole. And then we have also the final, which is given in the theory, which is 2 moles cuprous chloride. Okay, this one, in the reaction. Okay, now, sa iodine, bila man natong iodine, so wala. Kung maghihatag no iodine in the problem. So we don't have initial. So iodine is X. Okay, in the final, or in the equation or the chemical reaction, we have iodine, so we have 1. So 1 mole of iodine. So use this value in your ratio and proportion. Okay? So this is also standard. Ratio and proportion is standard in mathematics and in science. Ha? Okay? Assuming lang yun guys nga, you are using similar quantities to be paralleled. Same quantities lang yun siya per me. Hindi mag-rumble-rumble siya. So if you use number of moles sa lang usa, ganun siya ay pag-touch sa grams. Okay? But state initial, final, ganun. Okay? Let X is the number of mole of this substance. Okay? Let Y the number of moles of another substance. Because it's impossible also that there's no given in that problem. So that's why makuha rin mo siya kay di na siya ma-magic mo by given. Either 2 have given or 1, and then use the constants or use the formula or equations or the table in the handbook in the chemistry. Makuha rin na siya labi na yung mga standard chuba chuchu at STP. Kasi gusto lang dyan siya ang given, makuha mo ang uban. Basta mag-ratio and proportion ka, pareho lang dyan siya quantities. So mo na yung dumanha. Okay? Yung anak per me ang engineering course. Okay? So, if we have 14235, so we want to ratio and proportion of cuprous chloride. So, if we have 0.4235 mole of cuprous chloride in the actual that we produced, okay, over the number of mole of cuprous chloride theoretically in our chemical or balanced chemical reaction, which is 2. This is the 2. Coefficient of 2 is equal to, because if we deal about ratio and proportion, we need to take into account, guys, that we are dealing with equilibrium. Equilibrium, equal state. Okay? Always treat that the same as the law of conservation of mass, law of conservation of energy, okay? Law of conservation of atoms, masses, energy, ganon, and matter, law of conservation of matter, okay? So, meaning to say steady state flow, independent of time. We are not taking into consideration the time. If we talk about steady state flow, treating time as a constant, meaning to say, if we say ratio and proportion in solving mathematics problem or science problems, we need to understand that that is independent of time. Okay? Because at the steady state, and that is the time, we will employ the equilibrium state principle under law of conservation of either mass, energy, and matter. Okay? But the parent for that is the law of conservation of matter, subdivided into law of conservation of energy and law of conservation of mass. Now, the law of conservation of energy usually applied in physics, okay, and thermodynamics, and like that. And the law of conservation of mass usually applied in chemistry, okay, chemistry, quali, and physical chemistry. Okay? Because masses and amounts, stoichiometric relationship, and chemical calculations, it's in there. Iba kasi yung mga energy, chupa-chucho, di ba? Parang na sa physics, sa mga internal energy, mga heat energy, di ba? Kinetic energy, potential physics, ganun siya. So I am talking to the flow chart, okay, of the principle of chemistry, okay, like that. Because basically, physics is coming from chemistry. Okay? Why? Because the physics is the branch of science that tells you study of matter and energy. Now, you cannot proceed physics without matter. And matter has been studied in chemistry. Okay? Because the definition of physics is not only for energy. It states that it is a branch of science that deals with study of matter and energy. Dili pwede siyang energy lang. Kaya matikwang siya. Na siya pares nga matter. And matter is anything that occupies space and has mass, and it has been studied adequately in chemistry. So we can say, and therefore we conclude, that physics is originally came from chemistry. Okay? Okay, dili siya stand alone. But chemistry is a stand alone. Even though you will not study the energy thing, we can still study chemistry. Why? Because that's all about substances, matter, like that. Not necessarily dependent with energies. But physics, it's not. You're studying with energies and motion and blah, blah, speed and everything, acceleration plus the matter. So, it involves chemistry at the same time. So, it is dependent on chemistry because of the matter thing, M-A-T-T-E-R. But chemistry is a standalone pure science because we can study chemistry without energy, okay, by focusing on matter alone and its chemical changes, physical changes, chemical properties, physical. It doesn't necessarily need to move or to have motion, right? When we do mixing in the laboratory, in the quantitative chemistry, qualitative chemistry or laboratory, does it need to move the chemical reaction from point A to point B? No. It's stagnant. Though it's moving, but it's stagnant there in the beaker or in the flask, right? That's what I'm trying to point out. Nakakaloka. So, dili kito ni mo ma-apply mga force is equal to force times distance, gabachu-bachuchu, momentum is equal to mass times velocity, impulse is equal to force times time. Hindi mo siya ma-apply dito sa chemistry lang yun siya per me. Though, chemistry also study that as an additional. But what I mean, not necessarily. We will touch energy. That's why we will study physics. Okay? Get the point? No, muna siya. So basically, chemical engineering is a combination of chemistry and physics, okay, plus mathematics, and the practical application of technology from conversion of raw materials into useful products in different industries. Okay, that's basically the definition of BS Chemical Engineering. Okay? Engineer man siya. So it involves with practical application of technology. So it has to do something with technology and the design, okay, in a larger scale. If you talk about engineering or engineers, right? So plus science, chemistry, physics, mathematics, like that. Okay? Get the point? Oh, no, na siya. Plus the technology, the computer, okay, anything, the apparatus, the vessels, the tanks, equipment, ganon, muna siya. Okay, larger scale siya, guys. Now, after cuprous chloride, okay, so cuprous chloride. So, iodine na ta. Yung ipares ng iodine. So, what is the initial for iodine? Oh my gosh, iodine is initial, wala siya given, right? So, X. X sa initial, or sa actual. And then how much our mole in iodine? Ato 3, 1. So 1 mole of iodine. So ratio and proportion, use the cross multiplication of algebra. X. 10. The X is the direction where to multiply. So X times 2, 0.4235 times 1. Then bingo, we can solve for the X. And this is the mole of I2 needed. So mole of I2, pila siya. I have no more time, guys, because I have another appointment. So this is the mole of I2. Then since we have the mole of I2, what can we do now? If we have the mole of I2, then there is also a molecular atomic mass of I2. Then in that relationship, we can obtain the mass of I2. Meaning to say there are two methods in solving the mass of I2 produced in this chemical reaction, having the basis of calculation, which is 4.235 moles of cuprous chloride. So two versions. The ratio and proportion, and the conversion equation solution. Ganon. Okay? So, your ratio and proportion answer will be equal also to this, 126.9 grams of iodine cost. Okay, ganon. Okay, time manager po guys. Charot! Okay, thank you so much for listening for this chemical calculations, stoichiometry problem. Later I'll be able to discuss some. Di ba enjoyable siya? Charot, charot lang. Okay, thank you so much. If you have anything to express well, then you can comment down below in the comment section. If you're not subscribing my wedding channel, then you can subscribe. And then click the notification bell for some newest updates of I Am Now a Singer, Channel Voice. Bye-bye, God bless everybody. See you later. Nakakaloka. Pupunta pa ako sa ano, mamaya. Charot. Nakakaloka. Bye-bye.